Welcome back to Math 103. This is video number 30 on growth and finance. If you can repay $3,000 at the end of every year from 2016 through 2019, what is the total amount you can afford to borrow at the beginning of 2016? We have already solved this problem for 2016 through 2018, that is to say, making payments in 2016, 2017, and 2018, and seeing how much we can borrow based on each of those three future repayments. Well, when we throw in one additional $3,000 payment at the end of 2019, that entitles us to borrow this additional amount of money in the present at the beginning of 2016. Just as this expression is what we obtained when we solved for PV in the compound interest formula for that one particular loan from bank number 1, where we were only going to be in debt for 1 year, this expression is what we obtain when we solve for PV in the compound interest formula for the loan at bank number 4, where we're in debt for 4 years. Thus, each bank lends us a different amount of money at the beginning of 2016. Each bank lends us an amount of money equal to 3,000 times something. 3,000 times something. What is that something? It's a something that reflects how many years we're going to be in debt to them before we pay them back. At the end of the day that we take out our 4 loans, we get 4 different amounts from the 4 different banks, and they total up to $9,719.16. So we get to borrow this amount of money today to pay back, eventually, a total of 3,000 plus 3,000 plus 3,000 plus 3,000 will eventually pay back 12,000, so this is a plausible answer. Wouldn't it be great if there were a shortcut? Wouldn't it be fantastic if there were a formula where you could just plug in the amount of each payment and the interest rate and the number of payments, and it would just crunch out the total amount that you can borrow up front? Well, there is such a formula, and here it is. In this course, we won't get into where this formula comes from, but it's really not beyond you. It would just take more time than we have. The inputs to this formula are familiar to you. PMT means essentially the same thing it did in the previous formula. It's the amount of each payment, but in the sense of the amount of each regular loan repayment. I still means the interest rate per payment period in decimal form, and N in this formula, as in the future value formula, means the number of payments. So the number of payments until the loan is fully paid off. As with the future value formula, you have to be a little bit careful here with your parentheses and your order of operations in order to compute correctly. Let's use the present value formula to find the total amount that you can borrow at the beginning of 2016 if you will be making $3,000 annual payments at the end of each year from 2016 through 2025. The APR, as in the previous problems, is still 9%. It's still compounded annually. So in other words, we're just taking the previous problems and we're extending our repayments all the way out to 2025, still $3,000 a year, and we're asking, based on all these many years of repayments, how much can we borrow now? This would be a nuisance to compute without a formula, so let's see what the formula gives us. We substitute in the values that we know. We have $3,000 for PMT, we have 0.09 for I, and we have 10 for N. The number of payments is 10. There's a payment in 2016, a payment in 2017, etc., and the last payment is 2025. So if you count from 16 up to 2025, there are 10 separate numbers there. When you compute, this expression turns out to equal 0.557589193. You don't have to carry quite that many digits, but you should be carrying at least 5 or 6. When you compute further, it turns out this whole expression equals 19,252. As real-life applications of math go, this one is quite important. Knowing how much you can afford to borrow based on an idea of how much you can afford to pay back later is a very important thing. And now our most realistic question yet, even more compelling than the previous one. Suppose that you know how much you need to borrow right now, and the annual interest rate is, say, 12% compounded annually. So just to mix things up, we'll consider a different interest rate now. If you make annual payments beginning 1 year from now and ending 15 years from now, how much should each of your annual payments be? Now this is important. It's common that you would know how much you need to borrow now. For example, you know how much you need for school now, or you know how much you need for a car now, or you know how much you need to buy a house now. Using the present value formula, try to set this up and solve this problem before going on to the next video. Keep in mind that now it's the value of PMT, it's the amount of each payment that you have to solve for.